All right, in this video we're going to be adding and subtracting radicals. Now the most important thing to notice or to know about adding and subtracting radicals is they have to have the same index, so they have to be the same type of radical. So for instance, if I look at number 7 down here, these two radicals possibly might go together, but this guy over here, he's a square root, so he will never go with the other two. If I could reduce this 8 here, I might be able to get these two to like mesh together or like subtract together there, but the first one has no hope. So like also looking at this one here, maybe these will go together because they're both square roots, but this one will never. I can reduce this one, but this guy will never go with the other two because he's a cube root. Okay, so that's the same index. Next thing is the same radicand. So the radicand is the stuff inside, all right? Like these are both square roots. So the radicand is 63 and 28 right now. You cannot add these together unless those are the same numbers. And so you have to reduce it first to be able to do that. So adding and subtracting is kind of annoying because it's like you have all these problems to reduce and then maybe you can put them together after that, all right? So, just the basic thing to know about adding and subtracting radicals is this. If you have, like, let's say you have like 6 radical 2 plus 4 radical 2, basically you say to yourself, it's like, 6x plus 4x is 10x. So you have 10 radical 2, okay? So you have 6 of them and 4 of them, so you have 10 radical 2's. And so that's just the basic idea. The numbers in front, add or subtract, whatever they're doing, and then the radical just stays the same. All right, so looking here, these radical 10's in number 1, they don't reduce at all. So I have 3 radical 10 minus 8 radical 10, and then I have plus, remember that's a 1 radical 10 in front of here. So basically all I'm doing here is I'm taking the 3 and the minus 8 and the plus 1 and putting that together. So 3 minus 8 is negative 5. Negative 5 plus 1 is negative 4. So I have negative 4 radical 10 is my answer here. All right, and just one little thing I didn't go over here. So like radicals would be here, all right, because these are both cube roots and they both have a 6 inside. So those are considered to be like radicals, just like terms. I can add and subtract like terms. Now in the last video you saw we could multiply and divide radicals. They just have to have the same index. The stuff inside didn't have to match, but for adding subtracting it's more strict. So unlike radicals would be like this. These are both cube roots, but one has a 5 as a radicand and one has a 6. So they're not considered to be like radicals. All right, so number 2, I got some work to do on number 2 to see if I can put these together. So radical 63. 63 is 9 times 7, so 9 comes out, so I get 3 radical 7. 28, I would use 4 times 7, so 2 radical 7. So good, so this makes 5 radical 7. Over here, number 3. Right now, cube root of 32 matches for both, so I can not reduce this yet. They're already like radicals. So 2 minus 7 is negative 5, and I got a cube root of 32. And so now that I've done that, I can go ahead and reduce the radical 32, the cube root. So cube root 8 is a good one to use. 8 times 4. The cube root of 8 is 2. So I'm going to bring out a 2 and put my cube root of 4 back. All right, over here, number 4. So I do want to reduce all of these so that I can see if I can put them together. But remember, this guy will never go with the other two because he is a cube root. So 5 radical 2 is all reduced, luckily. 16, let's see. A good cube to use is 8 times 2. So I got 5 radical 2 minus a cube root of 8 turns into a 2. So the 2 comes out. 2 times 8 is 16. Cube root of 2. And then plus, now I know I want a 2 inside if it's going to go, so let me try that. So 2 times 9, perfect. 9 is a cube root, a square root. 9 is a perfect square, and so the square root of 9 is 3. So 3 times 4 is 12, radical 2. So it turns out that these two will go together. So I have 17 radical 2 minus 16 cube root of 2, and that's it. All right, down here, number 5. They're both square roots, so that's helpful, or that's hopeful, I guess. But we need to reduce these to see if they're going to match, okay? All right, so let's see, 20. 20, I'm going to use 4 times 5. So 4 comes out as a 2. That makes this a 6. I'll leave some space, put my 5 back. And this is a square root, so 2 goes into 3 once, so one more x is coming out, making x squared, and one x is left in. Okay. All right, over here, 45, I got 9 times 5. Okay, so 3 comes out, making that a 15. Leave some space, put my 5 back, so it's starting to match. And, oh, good. There's nothing, the x inside is done. I just leave it there. And then outside I still had x squared. All right, so what matches here, two things need to match. I got my radicals, they match. But, you know, the things in front, look at those. This part and this part, those have to also be like terms, and they are, right? So I have 6x squareds minus 15x squareds. So I have negative 9x squareds with a radical 5x. Okay. All right, for number 6, annoying problem. It's not too bad, but anyway, they already match, so I can put them together. I get negative 5 cube root of 32 p to the 8th, and I can reduce them here. All right, so 32, a good one is 8 times 4 to make a cube root. So 8 comes out as a 2, so I get negative 10, leave some space, cube root of 4. And 3 goes into 8 twice. So I get P2 and 2 left. All right, this last problem here. Again, remember that I have no hope. This one has no hope of going with the other two, but I still need to reduce it. Oh, 16 is a perfect square. So the square root of 16 is 4. So 4 comes out. 4 times 3 is 12. Leave that x inside. Over here, 8. 8, 2 times 2 times 2. So 2 times 7 is 14, and cube root of x minus cube root of x. So remember, there is a 1 right here. And when I look at this, these are both cube roots. Even though this x matches those other x's right here, it's not the same type of radical. This is a square root, and those are cube roots. So he stays alone. So 12 square root of x. 14 minus 1 is 13 cube root of x.